I'm Mike Krygeris, and I'm from Kentik, and I've actually been here for a year. I come from a background, my whole career has been on the vendor side. I've worked for 22 years previously in the essentially monitoring and observability space. What I really wanted to talk about today is, as a solutions engineer, is maybe some problems that people have seen and solved with the product, right? So that kind of gives you an idea about what we can do, and then maybe do a little bit of a demo on some of the features and functionality in the product, and we can play some stump the chump. We've got some chatty people asking some really good questions. So I've spent the last year really diving in as much as I can on the platform, and I think I understand enough to answer a lot of these questions. So with that, you can bear with me on that. I'll just kind of get going with this. So where did Kentik come from? Initially, a lot of the tools for monitoring were really kind of clunky. They were like single use, so they were either SNMP or maybe they were just NetFlow. They were monolithic, pain in the ass to manage, right? So they're always tipping over, and they always just barely work. So what Kentik's founders set out to do is to create something that took that problem away from the users that are experiencing them. So taking these really, really large scale flow data sets and SNMP data sets and providing a really fast query engine in order to get that information back, right? Be able to answer the questions that people are asking about their network to help, get outages out of the way, that sort of thing. So they didn't really have any good alerting, and they were very focused on like individual devices and all that stuff. So what they set out to do is, hey, let's come up with the perfect product for the problems that we're trying to solve for ourselves. So what they ended up doing is growing something that created things that customers like Twitch and eBay, Box, tons of customers are able to use this in our SaaS environment. So they don't have to worry about going to buy boxes or, oh, there's a shortage of hardware, and now what am I going to do? And I got to shut off one of the collectors, whatever, that sort of thing. That's our problem, right? And so we do it very well, and we provide a very good service for them. So if I look at this, our current ingest in our US cluster, 8 million records per second. Not a problem for us. That guy seems to be having a problem. We're not having one. So when you think about this, it's 8 million records per second. Even if you're just grabbing them off the wire and slamming them into a database, that's a really hard thing to do. What we're also doing is enriching the data. So we're taking all kinds of different data sets and we're combining those in real time to create much bigger records that have much more context to them, and giving a data set and a fast query engine for people to actually be able to pull those back and make use of that information. A lot of times people think about observability, or they hear that term and they think it's, oh, this is a marketing term, blah, 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 it's just monitoring. But I really think there's something different about that. And so there's an engineering term for observability. I wanted to go look and say, okay, what does this actually mean? I'm going to Google observability. What does it mean? So I go to Wikipedia. So this is the definition that it gives me. It's a measure of how well internal states of a system can be inferred from the knowledge of its external outputs. So the data that the network is emitting is going to be telling us what's going on in it. So if we can take as much of that in and make sense of it, then that's what we're going to call good observability, right? So network observability is what that is. So we're taking data from all types, all places in your network. So whether it's your internal network, data center, whether your cloud environments, GCP, AWS, any of that stuff, we're taking all of that in and painting that one big picture, and that thing, that system, is your network. So that way you have all of the information that you need to get the information out when you're asking a question. When we look at this, I'm just going to pick on AWS for a minute. what does a flow log look like? So you can probably recognize a couple of things in here. Maybe, the IP addresses, they're probably the source and destination IP addresses, but it doesn't really tell you a whole heck of a lot. So if you're collecting those and you're pulling those in and just putting them into a database and then saying, all right, let's run a report on those. Oh, cool. The VPC ABCDEFG 1, 2, 3, 4, 5, 6, 7, 8. Okay, now what do I got to do? Well, I can see something's going on there, but now I got to go figure out what that is. So rather than make you do that, that's what our enrichment does, is to basically take that context and give you a little bit more information on that. So if I go to the next slide, I can take a look at things and I say, okay, now I can look at things like the instance name, right? The VPC name, this type of information. We are also adding things like, geographic information, the traffic path that's coming through, DNS information, anything we can kind of get our grubby hands on in terms of getting that. So that can be also AWS tags in the environment, so you're tagging. So we can use our hyper tagging infrastructure in order to grab that and customize any type of flow. So it's not just AWS flows or whatever, it could be in your own data center. We can take that base flow information and then we can take other metadata that we're collecting elsewhere or that you're actually putting in via our hyper tagging API or whatever, and add to that so you can have a custom data set with full context of whatever it is you want. Okay, so that becomes a really, really good case, and that's what I think is really good observability. So because you can ask the questions, you can trend based on things, you know where your network boundaries are. So I know, we know where the boundaries are of the network in AWS, so we can basically say, okay, it's leaving the network. Where is it leaving the network? So that's another thing that we have. Cloud ultimate exit, cloud ultimate exit type. Those are things that say, okay, is it leaving through an internet gateway or is it leaving through a NAT gateway? I don't know. We're going to have that information. That's not in that flow log we saw just a minute ago, right? So we're adding all this context, which makes it a lot easier to answer those questions. So people that run AWS NAT gateways, does anybody know, like, that's kind of an expensive thing, right? So I kind of like to think of them as a printer ink of the cloud. People need them, but they don't. When they get the bill, they're not usually that happy. So this is kind of a good meme. I found this by Queenie Pig. There's some much funnier ones in the thread that I found that on, but I couldn't put them here. So take a look, maybe take a look those up, and that would be a lot of fun. But yeah, so that's the surprise thing. And so the reason why I kind of brought this up is I actually worked with a customer last week on helping to identify this information where they had a problem, and basically they got one of those surprises. What was going on is they migrated. So this is very common, right? People are migrating an application from the cloud, and what was going on is, I think, I didn't even ask the question. The application was using S3 to store data, and so it was on an on-prem environment, processing the data, pushing it up to S3, no problem. The only thing they're paying is their internet costs from the data center. So you take that same application and you take the same approach, and so what ends up happening? Well, I'm just going to send this out to the internet, and it's going to go to S3, and everything's going to be happy. But where is it going? Well, it's going to go through a NAT gateway, which is going to cost you 4.5 cents per gigabyte. So this shows us all of the cloud-to-cloud traffic. This is stuff that's leaving their cloud out via the internet. So we've got transit costs. We've also have NAT gateway costs. We look at this and say, okay, so we tag the destination service of where that traffic is going after it left the NAT gateway. So this is all happening automatically in the background. But I can see the public cloud destination here was if we can maybe zoom in a little bit, it says it's almost 63 terabytes in a week of traffic. So that clearly is going to be a very expensive endeavor, right? So when we looked at this, we were able to quickly identify, okay, what is this traffic? It's S3 traffic. So what if I told you? I can't even do Morpheus at all. But that's kind of where what I felt like, you know. And I said, you know, you don't have to do this, right? So when somebody migrated the application, really what probably should have happened is use using a VPC endpoint, right? And so essentially that is it's just like a patch port from the VPC to S3. So it doesn't have to go through that NAT gateway. That traffic didn't have to go through that NAT gateway because it was going outbound. So so instantly, so that cuts any transit costs and then $150,000 a year in NAT processing costs. Huge amounts of money. So really, so if I look at this, this is what it looked like afterwards. So we can see the cloud-to-cloud traffic that's coming out the NAT gateway. This is, you know, the lion's share of it is EC2, and even that is only is 10 terabytes, right? And then the S3 stuff is way here at the bottom. It's 0.2 terabytes. So that's a good before and after. You know, once you make the change, we can see, okay, did it do what we wanted it to do? Sure. I even have another one here that shows what the traffic is going now outside. It's going from here. It's not going out a ultimate exit. So the ultimate exit would be a NAT gateway if it was going out. So we can verify that. Now we can see the destination gateway type is a VPC endpoint. So now we have the verification. We don't have to weed through a whole bunch of logs, try to figure out what's going on. Really quickly.
This is on a flow by flow basis or something like that.
Every flow is, in this case, every flow is counted.
Yeah.
So we're just doing aggregations based on the tags.
Can you annotate the data with like the cost? So if you knew the NAT gateway was going to be 0.45 cents per transit, and you were doing 60,000.
That's an excellent question. That's actually a feature question. We so we do this with regular transit traffic for service providers, and that gives us the ability to, you know, track costs and that sort of thing. We don't do that with AWS right now, but that would be something that we probably could set up a plan for. It's just slightly different in how it works. Generally, transit providers, it's in like megabits per second or gigabits per second. So rather than actual totals. So, but we can run the reports on these. And so that's kind of where I figured that out. It was a good question to ask because you're like, why didn't you just show the bill? So yeah, no, I had to do the math, but that is something that we would like to do. Cool.
Well, just being able to see how much traffic there is outside of the network, how much traffic is between, like, this is incredibly valuable data because we just think of traffic, period. I see a certain amount of traffic that's coming out of that VPC, but where the heck is it going?
Right. When you're thinking about it and you're like, is it going to another cloud service? Is it going to, you know, anything? You know, is it going out of the country? You know, all that stuff is easy, really easy to answer with our query engine. So we're showing the Data Explorer. My sales guy, I geek out on the Data Explorer like this all the time. I love it because there's so much stuff. You can just slice and dice and aggregate and all that stuff, and it's nice and quick. And so, like, basically, that's the quick show and tell as far as like what, you know, that little scenario was. The next thing I kind of want to talk about is in cloud environments, it's really kind of hard to describe. So if I had to sit down and say, all right, here's how my VPC is set up, that's kind of what I sound like. I'm having a hard enough time describing what I'm talking about right now. So, so when we look at that, we've got Charlie talking about trying to explain what's going on in the network. So what we do is we use the metadata that's in the configuration information for the cloud providers, and we use that to build these really nice maps. And they're not just maps; they actually help to figure out like how traffic is flowing through the network. We can look at things like we can filter based on IP addresses if we want, any of the data actually in this map or any of the maps that we have. And so that gives us the ability to demonstrate exactly what's going on and then actually see how traffic is flowing. So if there's a misconfiguration, it makes it really easy to see what's going on, where things are traveling through. You know, is something going through a different VPC? And by the way, this isn't like per account or per VPC. This is the entire infrastructure that you've had. Once you've onboarded it, all that metadata comes in, and this kind of creates this thing. The other nice thing about it is as you add more tenancy to this, the icons kind of shrink down and turn into smaller icons. So it still looks really nice when you do it. And it all fits in the same page. So it's really nice. We have some very large customers that have very, very broad, diverse cloud environments. So this makes it really nice.
One of the things on a graph, because you have graph data, a graph visualization is often based on here I am, like you are here, and then I ultimately look at adjacent nodes. And so here we're showing it as a visual representation of a logical structure, and you're sort of confined to that structure. Is there an option where you could go and say, like, I'm going to take this flow, it goes to this point, and this point is this VPC, and then that's had the VPC is one EC2, and now I can make that the context. Now this EC2 talks to these things, like, and where the context changes based on where I'm looking right now.
Yeah, so one of the things that we have, and I think this is going to be part of one of the upcoming presentations, is the ability to look at the connectivity of something through AWS. So we can actually go through and say, all right, show me, I have this this instance, right, or this subnet. Tell me how it gets to this other instance or this other subnet, right? And so we can actually track that through. And a lot of people really like this functionality because it tells you, okay, here's how it gets here, or there's no route to the host, or it's getting blocked by a gateway or something like that, right? So, so people like to use that to try to validate whether connectivity is working. If it's not working, like, where is it not working, right? So is that kind of in the neighborhood of what you're
talking it's more
about?
like, so the advantage you've got, your visualization can adapt to where you're beginning. Because if you look at bringing on a cloud ops person, maybe you want to touch the developer, you want to touch the network. Each person can have a different way in which they want to begin looking at the data and visualizing. And like, I'm handing you the one of the most difficult problems to solve, but that idea that I would care about the container. So I look at the container and then I see the adjacent nodes it sits in a pod, on a node, in a cluster. And then my network person would say, she's going to say, oh, look at this. I care about the fact that this is in an EKS and it's on a VPC, and that VPC is a peering network to this other thing where this other service. So she's looking at it from that point of view. And then I've got a grumpy old server admin who's just like, I've got all this weird traffic coming back to my on-prem data center. And so he's going to look at the VPC, the edge of the VPC is, I don't care what goes beyond there. And being able to move, because you've got all this data.
Right. And that's the big bingo, right? So I'm going to bring this up in our demo right here. So this is an interesting thing, because I was, having these conversations about people in these different silos, right? Like the people who are running the Kubernetes clusters aren't necessarily people who are running for putting the IaaS infrastructure, the infrastructure as code or whatever. They're building this stuff out, but they're not necessarily the ones that are running the infrastructure. So this will show you, okay, here's how things are running as far as the traffic flowing through this specific cluster. So we can see what's going on. So this is a sock shop. So it's a fake website that sells socks that we use to demonstrate these things. So this really kind of gives us the ability to look at what's going on, how things are flowing through the network. And so if I go and show details, I can kind of dig in a little bit to some of the information, like the route tables over here and ACLs and AWS. So I can look in here and I can see, like, oh, here are the the denied traffic that's happening. So I want to try to figure that out. Like, is something not working? Is somebody complaining about that? That gives us the ability to look at that from the AWS side of things. Now on the Kubernetes side of things, I can do this, and this is totally beta stuff. So, but it'll be good to show, hopefully. So we're going to pivot over to.
You're obviously grabbing the entirety of the 5-tuple of every flow, so you can actually see. Because right now, of course, we see denies is generally going to be just L3, not going too much higher. But what we will care about more in that Kubernetes world, especially, is I'm going to have source destination port. I won't even have an IP address. necessarily. It's just purely going to be port level traffic that's going through a mesh potentially, or something that's much more difficult to understand what's going on.
Right. So to kind of to help you understand, so on the Kubernetes side, so we have the Kentik Kube stuff, which is which Ted had mentioned, eBPF client. So we do a couple of different things. So we have a deployment that you push out, and so it goes on to each of the nodes, and so it's doing a couple things. It's using eBPF to look at connections and looking for latency and that sort of thing. And then the other thing, using packets to build flow cache. So you're getting the flows and you're getting the performance data via eBPF through that, and then we're pushing that to basically an aggregator pod, and that data ends up getting pushed out to Kentik. So from here, we were able to say, okay, here's what the cluster looks like, right? So now we've got a couple of different clusters, and we can look at the pods or each of the clusters of how things are set up. I can go in, dig in and say, show me. I'll just switch that over. And if there's like high latency, that'll kind of surface it up top. We'll say, oh, these are experiencing high latency. There just isn't anything right there. Here are the different namespaces, right? So not something that you might not see that in the AWS stuff, but we want to dig in and take a look at what's going on as far as the Kube system. We'll use the Kentik one. We'll see. What does that look like? So I'm going to show all the pods in that namespace.
So you're basically running it almost like a sidecar to then push that data out.
Right. We're not running sidecars, though.
You're actually just running a live container. Because you're using eBPF, you don't need a sidecar. You can.
Yeah, we can just use that on the node itself.
Right.
So I guess there's some people who use sidecars, and then some people that don't. Like some people hate them, some people love them. I don't know. So
yeah.
like I know like AWS Atlas or whatever they have. I think they all run sidecars on all of their pods. Some people look at that and say, well, that's a lot of compute, even if you're running a lot of containers in every pod, right? So it's a trade-off. It's probably 6 of one, half a dozen of the other, but I think this is a really great approach.
I agree. eBPF would be the right way. It's just because I'm just thinking the application layer to get further up, like you've got a really strong application play that is not necessarily apparent right now, but it's going. I can see where roadmap is arriving, and when we get to the cloud folks, they want to see an app as the context.
You got it. So at large, we're going to run as a daemon set per node.
Right.
With that eBPF showing us what's going on for every tunnel, that's going on top of that, we'll get those flows underneath. That's where our strong suit is. And then we can relate that to the apps as they're running, understand which system calls are being run, what that context is, and bubble all that entire stack up at that point with the eBPF help assist underneath. But we do need to be that daemon set on every node.
Right. Otherwise, there's no way. Otherwise, you basically have to sit as a sidecar to every single thing to the kube proxy to let our IP your performance if we do that. Yeah.
So yeah, that's very good. And so I'm just kind of wanted to dig in and show you this a little bit of links to show you like what the containers are in each pod. Obviously, just one. There's no sidecar. This is these are the actual pods that are running for that on these different nodes. So just kind of give you the information, the performance information. So that's kind of what we're doing in terms of being able to provide additional performance and flow information from within a K8 environment. So
you have the start time and end time of the pods, and so you can actually track life cycle as part of your metadata.
Those actually should be part of the flow data that we're sending. I don't know if it's going to say, okay, here's a start time, but these are going to start traffic pretty much right away, right? So you're going to have that record that this thing was around for this amount of time, and then so being able to also add additional context in like using that hypertagging API, we could use that for the Kubernetes stuff. So you want to label things 6 ways to Sunday, you would be able to just do that with those flows. So it's all just, if it's flow like data, we can bring that in.
Because the Kubernetes thing is particularly tricky because it's ephemeral pods that have the same name, but they have different IDs that get generated. But if you at least use labeling and lifecycle of the pod and lifecycle of the container, then you can map that over time. And as I said, flow is this one of the central things. But if maybe you have 5 instances of a pod, and then you have 3, and then you have 1, and then you have 5 again, but there are 4 new ones. They aren't the original 5. So being able to track that state over time is particularly important.
Yeah, it's a unique idea, and that's one of the things that somebody, I'm not even sure if it's in here now, but like it's basically is it the app name or something like that we're calling it? I'm not sure, but so there's the so there's a pod name and it has that
Some random
those random identifiers at the end. So it's basically the ask was like just chop that stuff off, and then so now we can aggregate on. So we have another label on that, so we can do that. So I'll say, oh, all my Kappa agents, I don't care, I can delete them all day long, and I'll still have the ability to report on those specific applications. But then I still have the pod names if I need to dig into that, right?
Mike,
Yeah.
if you looked at Data Explorer with the process-aware telemetry,
Yeah.
I think that goes half the conversation you guys are having today.
Yeah. So this is where I go into Data Explorer and geek out. So when we go into this, I'll go into look at these, and so I can go and we have this process-aware telemetry agent, and really so the reason why it's called this is because this eBPF agent actually it can run on a regular Linux, whatever machine, and send the data that it's collecting out of this. So we have that, and then we'll have some dimensions. So when we go into this dimension thing here, we can see all of these different dimensions that we can choose from, and these are available based on the context, right? So we have this, and then I can say process.
Because we even have beta support for Windows now for eBPF. So life is getting better by the day. That becomes the protocol of choice.
Does it work?
It works, but just no one wants to say it's officially supported yet.
Okay. All right. Good. Because that's usually the problem. It doesn't quite work. So yeah. So just kind of showing here. This is showing us the processes, right? So just the raw processes. But then if I go in and I want to add things like pods and stuff like that, I'll go and look and.
So
That's why these are 2 different things.
You can use your hyper tagging at the process. So you can basically apply tags within Kentik that are then held in Kentik, but at least,
Yeah. In this case, we're able to get that at the point of generation, right? So we're getting that eBPF information from the agent on there. So now, we can do the enrichment right there, right? And then we can send it in, and then we can do additional tagging if we want. So this is where it shows us, the information with the process name, the source pod, destination pod, that sort of thing. And then there's different metrics that come out of that. So we could switch the metrics up to use latency or something like that. So just really, really powerful stuff to be able to dig in this far. And so I like it. And so we're constantly adding the ability to add new types of data. And our Kentik Labs people are just insanely talented in terms of the stuff that they come up with. Is just amazing and blows my mind. So it's stuff like this. I honestly, even in the Kubernetes experts say nobody's a Kubernetes expert. So I think I'm sort of up to speed kind of on like what Kubernetes does and how it works, but I do know how our telemetry agents work, and so hopefully I've answered the questions to the best of my ability.
You've done great.
So still trying to understand. So the flow records are summarized once a minute. So you're getting a flow record each minute for every flow in the network that's configured. And this massive database is getting 8 million of those records per second. And then you're annotating those records with the other dimensionality information from whatever agent to provide that. Is that annotation done in real time, or is that done?
Yeah, as it's being ingested. So we have basically what we're calling tagging. And so we're taking specific fields that we call out. And if I go in and take a look at how we set this up, this is just a GUI for this, but really what most
So it's not a connection-based telemetry, but rather a flow-based telemetry. Is that
flow-based? Yeah. So I mean, a lot of times a connection is going to be a flow, but if it's UDP, that you set.
I connect to a network or something like that, at my level, it's one type of transaction. It might be a gazillion transactions internally to connect, but my flow, on the other hand, is, I'm streaming whatever network transactions.
Yeah, the flow would be generally what we think of as a flow is 5 tuple of data, right? The source address, the destination address, the source port, the destination port. And so that changes from connection to connection.
Yeah.
So generally, but when we think about that, there's also the concept of key fields in that data. So on Cisco switches with flexible NetFlow, you configure a key field. So sometimes they can be a key field and sometimes they can be a non-key field. And really what that means is if it's a key field, if one of these things changes from one packet to the next, then it needs to create a new field. Some things people don't want to do that. Maybe for whatever reason, it could be a destination interface, it could be a DSCP value or something. They don't want new records created for every new one of these that happens in that flow. So they can make it a non-key field. So I think that's
could be a gazillion packets in a minute, right? Or,
yeah,
not a gazillion, but
yeah. So like yeah. So it is. It's metadata about the flow. We're not sending raw packets back to Kentik. We're the router or the device that's monitoring whatever's generating that telemetry is doing a sort of an aggregation to create that flow. So you say, all right, this specific connection or whatever had X number of packets and X number of bytes, right? And then we'll use that as the metric for that set of data that happened. So now we have an event. Generally, what people do with flows is if it's a long-lived flow, we will chop that into 60-second pieces because you don't want to wait a whole hour to get an hour flow. You want as many pieces as you can get. So generally, in most cases, most flow, it makes sense to do it every minute. You can get higher resolution, but that means you double your flow. If you set it to every 30 seconds, then you could double your flow for those longer lived flows.